Good morning. My name is Waibo Michael, and today I will be answering a question that is based off the Newtonian mechanics of motion. The question is: a delivery driver is required to pull a cart containing various boxes with an overall mass of 60 kg from his truck to a customer's front door. The cart handle is hinged at an angle of 60 degrees with the horizontal. He pulls it across a rough road with a coefficient of static friction mu equals to 0.6. If the distance between the delivery truck and the front door is 15 meters and it travels with constant acceleration of 0.5 meters per second squared, calculate A. the amount of pulling force required to perform this action, B. his final traveling speed right before he comes to a stop, and C. the time taken to travel from his truck to the customer's door. Right here is an image of the delivery driver pulling the cart with the boxes on it. By the end of this lesson, you should be able to A. understand the concept of forces acting on the direction and choose the proper coordinate system. B. identify and solve equations containing two unknowns. You should also be able to properly interpret and comprehend the use of kinematic equations and construct or model and utilize free body and kinetic diagrams. So, first you have to go with our givens. From the question, we can attain that the mass of the boxes is 60 kilograms. The coefficient of static friction, mu, is equal to 0.6. Initial velocity is 0. Initial distance covered is 0 since he starts from point 0, which is his truck. The final distance, which is the distance between his truck and the door, is 15 meters. Acceleration is said to be constant at the rate of 0.5 meters per second. Force of gravity is present as g equals to 9.8 meters per second squared. We can also assume that only linear motion is present, only the cut of the weight will be neglected, and all the sum of the boxes' weights will be acting from one center mass. We can also assume that the crate is a point particle. To solve this problem, you have to understand Newton's second law of motion, which states, or simply states, that force is directly proportional to mass times acceleration. So that is, force is directly proportional to mass times acceleration. In this case, the force will be going upwards in the direction of pulling, and they give us an angle of inclination, or the angle of pull, which is theta, and theta will be equals to 60 degrees, yes? Now, if you're pulling an object in the right direction or in the left direction, there has to be a force of friction pulling it backwards in order to stop motion. That force of friction will be acting this way, and let's call that Fk. All objects are acting on gravity from the center of mass, so gravity will be represented by Fg, which is equivalent to W, which is the weight of the object. The object will also have or exert a normal force back on it in order to prevent itself from crushing down, and we can call this the normal force. Now, looking at this, you'll be asked, what kind of coordinate system would you like to use? In this case, we have three forces acting in the x, y regular coordinate, and we have one force acting in a angled coordinate. So I assume, or I would say the easiest and best one to use would be the xy coordinate, with a little switch this time though. The y direction will as usual point upwards, but this time we'll have the x direction, the positive x direction, acting towards the left. Now, okay, so now I'm going to create the free body and kinematic diagram. Like previously stated, this is your x and y coordinate. This is your force, your pulling force, acting in this direction at an angle of 60 degrees. This is your normal force. This is your force of gravity, also known as the weight. And this is the force of friction, which is pulling in the opposite direction to stop motion. Now, this is an x and y coordinate system, also known as a rectangular coordinate system, so you can't just have a force acting at an angle. Hence, you have to break this force down into x and y coordinates. If you look at this and you draw this down, you can see that this forms a right angle, with F being the hypotenuse. So you redraw that triangle over here. You have theta, which is 60 degrees. You have F, you have Fy, and you have Fx. To solve for Fy and Fx, you use the basic geometry principles of SOHCAHTOA. So, opposite hypotenuse, ka, adjacent hypotenuse, tangent, opposite and hypotenuse, or toa. So, this is your opposite wherever the angle is facing, This is your hypotenuse, wherever the right angle is facing. And this is your adjacent, which holds both the right angle and the angle of inclination. So, to find Fy, you use sine opposite Fy, or theta actually, is equals to Fy, which is the opposite, divided by the hypotenuse. Therefore, Fy is equals to F sine theta. Now, you do the same thing for the adjacent. Adjacent, hypotenuse, cosine. Cosine theta is equals to Fx divided by F. So Fx is equals to F cosine theta. Yes? So now that you have that, you have your two angles, you can redraw your free body diagram. You can have still your normal force acting this way, your force of friction acting this way, your weight acting downwards, but now you have a Fy acting this way, and you have your Fx acting this way. Yes? Now, next thing you will have to do is also draw a kinematic diagram. A kinematic diagram just represents the motion of the mass in a specific direction in relation to its acceleration. So if you have the boxes as a point particle, m, moving into the left direction, a, x. X because it only moves in the x direction. This means that there is no motion in the y direction, therefore ay is equals to 0. So this is your kinematic equation, or your kinematic diagram, also known as an inertia diagram. And this is your free body diagram, FBD for short. Here they are in clearer view. Kinematic, also known as inertia diagram, and your free body diagram. Now, we will be using this free body diagram to solve for equations of motion. So now it is time to make your equations of motion. Like stated earlier, sum of forces is equals to ma from the Newton's second law. Now you have two directions, so you have the sum of forces in the x direction is equals to m multiplied by acceleration in the x direction. Sum of forces in the y direction is equals to m multiplied by acceleration in the y direction. But as we said in the previous slides, acceleration in the y direction is non-existent, so it's equals to 0. Therefore, sum of forces in the y direction is equals to 0. Yes? Now, in the x direction, you have two forces acting. You have the force of pull going in the positive x direction, so he has a positive sign in front of it. And you have the force of friction going in the opposite direction, hence the negative sign, which is equals to m times ax. The force of pull is unknown, but the force of friction is equals to mu static friction as the coefficient multiplied by n. So this mu is given to us as 0.6. So F minus 0.6 is equals to max. But we know that F acts in the x and the y direction. So as we stated previously, F in the x direction will now be F cosine 60 minus 0.6, which is equals to mass, which is given as 60 multiplied by 0.5 meters per second squared. So you have finally F cosine 60 minus 0.6 n is equals to 30. Yes? Now we repeat the same thing for the y direction. In the y direction, you have three forces acting now. You have the force of pull Fy in the positive y direction. You have the force of normal force in the positive y direction. And you also have the force of gravity. But gravity acts in the negative y direction. And gravity, W, is equals to m times g. Mass is given as 60. And gravity, as we all know, is 9.81. And is equals to 0. So you have Fy, which has given as calculated in the previous slide, F sine 60 plus n minus 588.6 is equals to 0. So F sine 60 plus n is equals to 588.6. Let's call this equation 1. Let's call this equation 2. So right here are the equations given again, written down in a more clear fashion for you to see. F cosine 6 equals minus 0.6 n is equals to 30, and f sine 60 plus n is equals to 588.6. These are two equations and hence can be solved in a simultaneous manner. Simultaneous equations, as we were taught in algebra, are two equations with similar characteristics that can be solved to satisfy or find answers that satisfy the two equations. So let's go from equation 2. F sine 60 plus n is equals to 588.6. You can rewrite this as n is equals to 588.6 minus f sine 60. Sine 60 is 0.8860, so 588.6 minus 0.8660 f is equals to n. Yes, so that's it. Now you substitute this back into equation 1. And if you do that, you have 588.6 minus 0.8660 f for n negative plus f cosine 60. Cosine 60 is 0.5, so 0.5 f is equals to 30. Now all you do here is you solve for f, and once you solve for f, you find that f is equals to 375.794 newtons. Make no mistake, this n here is for newtons and this n here is for normal force. Now you substitute this back into the original equation 2, or actually this one. You have n is equals to 588.6 minus 375.794 multiplied by sine 60, and n is equals to 263.16 newtons. So that is how you get the newtons for the normal force, and you get F, which is the force of pull. So basically, hence, the amount of force of pulling force required by the driver is 375.794 newtons. You could say the driver is in tip-top shape. So now we just saw time to solve for part B and C. Part B, which asks for the driver's speed right before he stops in front of the front door, and part C, which asks for the time to complete the task. We solve these using the two kinematic equations shown in this page. First one being this one, where final velocity squared is equals to initial velocity squared plus 2 multiplied by acceleration in the x direction, which is given in the equation or the question, multiplied by final distance minus initial distance. Remember, the initial distance is 0, so you can cross this out. Initial velocity is 0, so you can cross this out. You substitute all your values. Final distance traveled, which is distance from point A to B, is 15, and you get v squared is equals to 15. Square root of both sides, v is equals to 15 to the power half, which is square root of 15. I get that his final velocity is 3.873 meters per second squared. To solve t, use the second kinematic equation. Final velocity is equals to initial velocity 0 plus accretion due to gravity, which is 0.5, multiplied by t, which is the time taken to travel from point A to B. Substitute v, which is gotten here, and you have t is equals to 7.75 seconds. Hence, it takes the driver 7.75 seconds to arrive at the door and complete his task. Thank you. Hope you learned everything from this course and you're able to get to the learning objectives, and have a good day.